Hi everyone! Today we're talking about Bayesian Inference, a powerful way to update what we believe based on new information. Imagine you think it might rain, then you see dark clouds, a worried pigeon, and your grandma says her knee hurts. You're now more sure it will rain. That's Bayesian thinking. At its core, Bayesian inference combines what you already believe, the prior, with new evidence to give you an updated belief, the posterior. It's like giving your brain a mini software update every time you learn something new. A quick history. Why is it called Bayesian? Bayesian inference is named after Thomas Bayes, an English priest and mathematician from the 17th. He came up with a method to calculate the probability of an event based on prior knowledge, a concept that became the foundation of Bayesian thinking. His ideas were published after his death and have since shaped everything from artificial intelligence to medical research. So yes, a priest from the 18th century helped build the math behind modern data science. Bayesian inference isn't just a cool math idea. It's powering a lot of technology we use every day. Take spam filters. They use Bayesian logic to decide if an email looks suspicious based on patterns from other past email. In medicine, it helps doctors update diagnoses as new test results come in. It also big help in machine learning, where models constantly adjust their predictions with new data. Even search engines and recommendation systems use Bayesian methods to figure out what you're most likely to click next. In short, Bayesian inference is like the secret sauce behind smart, data-driven decisions in the modern world.
Bayes' theorem is a powerful tool in probability and statistics. But what exactly does it do? So it helps us update our beliefs based on a new information. Like, given this evidence, how likely is my assumption or hypothesis to be true? Now, let's look at the heart of Bayesian inference, Bayes' theorem. So, it's written like this. The probability of H given E is equal to the probability of E given H times the probability of H divided by the probability of E. The probability of H given E means the posterior probability or our updated belief after seeing the data, while probability of E given H means the likelihood or how likely the evidence is if the hypothesis is true. So, the probability of H is the prior probability or what we believe before seeing the data. And lastly, probability of E is the marginal probability or our overall probability of the evidence. This formula gives us a way to revise our beliefs step by step as we gather more information.
Why Bayesian inference is important? So why is Bayesian inference important? It is especially useful in uncertain or incomplete situations, which is almost everything in real world. Unlike traditional methods, Bayesian inference doesn't just give a yes or no answer. It tells us how confident we should be and updates that confidence as new data comes in. This approach is powerful because, so first, it allows us to start with expert knowledge or historical data. Second, it lets us adjust our model over time. For the last, it's ideal for dynamic systems like disease diagnosis, stock predictions, or machine learning models. So in short, it makes our decision making more flexible and adaptive.
So in this part, I'll show you how Bayesian inference used in real life. So first, what is Bayesian inference again? It's the process of updating our beliefs based on new information or evidence. And even though it sounds technical, we actually see it in actions in many parts of our daily lives. So let's go through a few examples. Let's start with something really familiar, the medical diagnosis. So imagine a doctor who thinks a patient might have the flu, so that's the prior belief. But of course, the doctor doesn't just guess, they order a lab test. So once the results come in, the doctor updates their belief based on the new evidence. And this process, updating what you think after getting new info, is exactly what Bayesian inference is all about. It helps doctor make better and more accurate decisions. Next example, spam email filters. Email services like Gmail use Bayesian algorithms to decide if a message is spam or not. So every time you mark something as spam or as not spam, the system learns and updates its filter. So the filter improves over time by updating its belief based on your feedbacks. So that's Bayesian inference in action. Another real-life use of Bayesian inference is in weather forecasting. Meteorologists start with prior knowledge, like weather patterns from previous days or years. Then, when new satellite data comes in, they update the forecast based on that fresh information. And the more data they get, the more accurate the prediction becomes. So again, it's all about updating based on new evidence. So, as you can see, Bayesian inference isn't just a math concept. It plays a big role in real-life decision-making, whether it's about health, technology, or even predicting the weather. Bayesian thinking helps systems and people make smarter choices as new information becomes available. So it's everywhere, even if we don't always notice it.
Now, let's explore some real-world application where Bayesian inference plays a crucial role. In machine learning, Bayesian classifiers enable systems to learn from data and improve over time by updating their predictions as new information becomes available. In finance, Bayesian methods are used for risk assessment, market forecasting, and fraud detection, helping institutions making data-driven decisions under uncertainty. In robotics and AI, Bayesian inference helps machines interpret noisy sensors data and make informed decisions, especially in dynamic or unpredictable environments. In genetics and epidemiology, researchers use Bayesian technique to identify likely causes of diseases, analyze gene expression data, and track the spread of infection using uncertain or incomplete information. So this system rely on updating probabilities in real time, which is exactly what Bayesian inference allows.
To recap, Bayesian inference is a smart way to update our beliefs when we get new information. We start with a prior belief, consider the likelihood of the new evidence, and end up with a posterior, a more accurate belief. It's especially powerful in uncertain situations, which is why it's used in fields like AI, medicine, and finance. In short, Bayesian inference helps us make better decisions, one update at a time.